Hello, welcome back to BlenderSushi Live Noding. In this video, we're gonna explore 3D voxels in Sverchok. Before I talk about this Magica Voxel, I'll switch to Blender first. So this is kind of a probably the final result that we're gonna create using Sverchok inside Blender. So what is this? This is just like a 3D grid voxel. You probably have seen me creating something that looks like kind of like a grid where you make like boxes at some point. But this is kind of something similar. But I will also talk about the dupli instancing in Sverchok. It's a I'll talk about a couple of things, but the instancer will be something that's important for working with a 3D voxel. Yeah, this is just like a random stuff. I'm basically masking the voxel procedurally. Don't worry about these triangles for now. Basically, this is the setup we're gonna create. It was actually inspired by this app called Magica Voxel by Ephtracy. Yeah, I found this tool the other day, and then I found this tool to be really interesting. It's super interactive, and it's also really simple and intuitive to use. Perhaps because it's I don't know. I think it's really well done. The way it's been created, so you can work with this voxel kind of cubes. It's really simple. If you're like a 3D artist, you've been using Blender for a while, this app kind of you are limited to voxel, but like in this one it's a 8x8x8 voxel, and then you just kind of you're attaching more boxes and maybe erasing boxes, and you can actually you can move the voxel in a X, Y, or Z, and it's gonna repeat up and down. I found that to be quite interesting. I kind of wanna do the same thing using Sverchok in Blender actually. Yes, I think this app really deserves to look at. Because, you can actually export this into Blender as well. Export and then export it as PLY or as bake mesh. It will bake the texture, and then this is really nice software, and you can actually just paint it randomly, you know. I haven't played much with it, I just tried it yesterday, and then this is really good software. Yeah, so we're gonna recreate something like this. It's a voxel model. Just imagine it's just like 8x8x8 cubes, right? It's really easy to create in Blender, right? Yeah, let's do it. So I'll start from scratch. Hopefully it doesn't crash. It's totally empty. File, save as Sverchok Magica Voxel. I think this is actually kind of more like similar to Minecraft. That's the app I was thinking. You're building using blocks of voxel, a little bit like Lego as well, but it's more like Minecraft. It's funny because say you're trying to recreate the same thing in Blender. Okay, perhaps you're thinking to do it manually. Okay, manually is okay. You can do this, and then it's totally fine. But I found it's quite tedious, and then okay, maybe you can snap it to the grid. Yeah, we're not gonna do that. You can also use particles, and then you can create volume and create particles, scatter particles. But not gonna do that. I will use Sverchok. Turn on Sverchok, create a new node 3, and I'll start with a plane. Actually, the other day in the previous live noding, I tried to create this 3D voxel structure, but I kind of failed. It was kind of silly, but I'll try to do it again. I'll attempt to do this again real quick. So we'll start with a plane. Okay, plane will generate us these points. It's a but it's like a 2D kind of grid. Okay, we can later instance boxes into this guy. So and today I will actually use instancer node in Sverchok. You can use either dupli instancer or mesh instancer. Mesh instancer is more robust, but dupli is simpler. And if you are working with voxels and just boxes, and the box is not gonna have like scaling in XYZ, just scaling will always be the same. Just use dupli. It's really simple. This is the node, how it looks like. It's looks like a specialized kind of node. I'll create a default cube in the 3D here, 3D view, and I'll source that cube. And now I just so there's a location and transform. Okay, locations you can use maybe random vector, just scatter some random vector. You might notice that if we are using dupli instancer, it's really fast. It's unlike if you're actually using the viewer draw or using the BMS MK2, because we are actually using the real instance of this object's cube. So if we have like the monkey, this is gonna be really fast as well. If we use Suzanne, see, it's almost instantly being created, and we can have like 1,000, 500,000. This is super fast, unbelievably fast. This is like a Blender's really efficient with the instancer. Anyway, let's go back to our cube and save this for now. Why we still have Suzanne, I have no idea. One object only. Okay. Why do we have that points? Weird. Anyhow, let's go back to what we're doing. It's we want to create a 3D voxel grid. So currently we have a grid, but it's 2D. If I plug that in, okay, that's what we got. The step, what's the step? I think it's 2. Yeah, I think it's 2. They're touching each other, and we still have the monkey somehow. Delete, and we have, what is this? Don't worry about that. Basically, we have this 3D voxel, and in order for the voxel to be in the position of the points, we need to zero out our master instance. Alt G. Alt G. So that's our cube in position. Now, in order to create a 3D grid, we need to kind of duplicate this grid up. So let's do that real quick. Matrix apply, and use a matrix in. And for locations, we either use a line, or I can use line, and just duplicate it up. Actually, just don't use line, use a proper one. Vector in, and we're gonna duplicate up, so it's in the z-axis, range, float in the z. Now we have kind of 3D points. Stop count. Let's use just step. We can have as many points as we want growing up. Now if I plug this into this guy, it's still not gonna work. It's still like 2D grid. Why is that? I cannot explain it, but we need to basically join the list in here. There you go. That's all we need. So we can see the points, we can see the final result of the instancer. The stepping probably need to be true. Okay, now we have a proper voxel grid. Let's the limitation of this is that we cannot have a single cube, but single cube is don't worry about that. So we can have as many cubes as we want. Maybe in this case we just wanna 8 by 8 by 8, just like the Magica Voxel thing. Yeah, so this is our voxel grid. We don't actually need to have the points now. So we have this guy, this guy. I will actually save it out. Remember, you know what I'm doing here, like exporting out to GIS. This is actually saving the node 3 setup as JSON. So this is SV voxel grid. Save it, and you can see this is saving as SV voxel grid JSON. Next time you open Blender and you want to create this 3D grid, you just reload the JSON. So I don't know why we have the dots there. Maybe I delete something. Maybe I'll restart and then compositing back to Sverchok and then just reload it. Reload the JSON. Here, go to desktop, voxel grid, and then yeah, we should have the cube. Oh, it's actually loading the cube as well, and we still have the dots somehow. Yeah, what is that? Maybe it's just the parents. If we look at the outliner, the boom, and there's a boom mesh and a cube. Okay, maybe instead of 8 by 8 by 8, let's reduce it to 4 by 4 by 4. This thing goes red somehow. Maybe I need to create a new objects. I'll create a new cube and reload it. Let's call this master. Let's load master. Save it as voxel, Magica Voxel. Okay, let's just work with this. Okay, let's see what can we do with this. Let's have a look at the mesh instancer as well, by the way. So here we can just plug in the locations. There's this transform thing. I think the transform, if we use a matrix in here and then use a random random number, for example, and then plug this into the scale. Let's just test this. We can randomize the cube. Although you notice that the location is now back to 0, 0, 0. We need to plug this into the locations. Okay, now we have now the parents is actually correctly being drawn. So I think this is a more correct setup. Locations and then transform one object only. What is this for? Don't worry about that. Maybe we can have multiple objects here, maybe. Oh yeah, so this is, apparently we can randomize the size, which is pretty neat. Randomize the scale like that. I really like this random number generator nodes, super handy. With this guy, you notice that the scaling actually is kind of like the same in all X, Y, Z. I don't know if it's a bug or maybe it's a features, but if you actually plug this into that guy and update it, let me load like a cube. Select get the cube. We will get a what is that? I think I should just work with one of this. It's just a little bit confusing. Try to do too much at the same time. Let's delete that. Call this master. Reload everything. Okay, we have too many random values there. That's why it's like that. 4 by 4 by 4. It's basically 4 by 4 by 4 is 64. So just give 64. Now we have just our voxel. With the voxel, really, we just wanna have the same size of voxel, right? We don't really want to randomize the size. In this case, we really don't need the randomness. What we want is maybe we want to kind of like masking the cube. So in order to do the masking, it's really simple. You already know about this. You just use the list masking, list mask out, and just plug this into the true, and then here you need the masking, and for that you actually need random number generator, and just use integer between 0 and 1 and 2. Let's check out the result here. 0 1 0 1 0. Sometimes you get the 2, which is okay, just random number between 0 and 1, then plug into the mask, and supposedly we're gonna get some. Okay, there you go. Some of them are hidden. Let's have like 64 of this. Yeah, so that's pretty much what I want to show you, except that this is just like the Magica Voxel, but this is doing this, it's creating this structure randomly. Let's see if we, but the cool thing about this is we can go with a really high value, maybe like 10 by 20 and by 4, 10 times 20, 200 by 4 is, now we have like 800 of these voxel cubes. With a Magica Voxel, you have like limited number of voxel. Okay, maybe randomize the seed further. In reality, of course, instancing is fine. This is actually a lot faster than doing the viewer draw thing. But you have less control of this, of course. You just you have control over the positions, and if you're doing like a voxel Voxel Art. Voxel Art. Just like a little bit similar to pixel art. You really want to have control over the position and then the color of the voxel, perhaps. Currently, we just have like a plain boxes being spawned randomly. Maybe at some stage I'll try to maybe make it less random but more structural. We can render it out using global illumination stuff, randomizing the material. I'll just use cycles. These days just all about cycles. Give it a materials. Okay, apparently I need to select the master and give it a material, and then now we should have that guy being rendered. I wonder if we can have a different color for this. Okay, this diffuse and then maybe random object info. Plug into the random. If this works, then we can randomize it. Otherwise, it's not possible. Oh yeah, this is not a cycles material. That's interesting because I'm changing the material, but still this guy is not. Okay. Selecting the wrong thing. Object info, random plugin there. Okay, we have a nice random value there. Yeah, just do the usual. You know the drill. Is just selecting a color, because we have this random vector. If the objects have different positions, it's gonna have random color. Looks like we have some kind of overlapping there. Something's I need to fix that real quick, but with the color here we can grab some random color just to test it. One more color, just yellow. Perhaps green. Back to Sverchok. Wonder why they're overlapping. Maybe the stepping should be 2.5. 2.5. But now we have a little bit of gap. If that's what you want, that's fine. Randomize the seed. You can tell that this is actually really fast. If we have like even like high number, like 100 by 100, actually don't do that. Maybe 30 by 30, 900. 900 of these objects. 900 times 4, 3600. Yeah, that's a lot of cubes, a lot of voxel, but this is really fast. And if you want to, I wonder, maybe in the next live noding I will show you how we can use a 3D texture to kind of do the masking. Yeah, I think that could be interesting. You can actually use noise here. So instead of random number generator, perhaps we can use vector noise and use scalar. And let's see how we do this. So vertices, the vertices can be from the actual object itself. Currently Blender seems to be frozen. Let's keep creating that. terminate. Just starting Blender real quick. I'll try to use a built-in noise node in Sverchok, but sometimes it's easier just to use the texture, the 3D texture in Blender. So we have this guy. Maybe we have too many objects. Back to 8. File, save as. Now let's get our random noise, vector noise, and the vertices can be from this guy, plug into that guy, noise out. With the noise, maybe we just map the range. Here what I'm doing is, see, this is noise, it's a vector noise, and we actually don't need a vector noise, sorry about that, just scalar. So we have noise like this, 0, blah blah blah. We're gonna remap the noise into value between 0 and 2, and let's check out the number now. Okay, now the next thing to do, just use math and floor the number. Plug that in, 0, 1, 0, 0. Now that's the actual noise becoming 0 and 1. Now we can use this as mask for our locations. And this noise is it's really more interesting than random. It's still pretty random, but you will see here that we can actually push the noise. Vector in, add, plug it in. I do this many times, just to be very clear. So that's a noise kind of passing through, and what's nice here that you can also scale the noise. So this is a vector, use another vector math here and then multiply by scalar, and use float here. See, I can make the noise larger or smaller. I think this is smaller noise. We can actually tell if we have more voxel, maybe 5, 6, 7, 8, 9, 10. 10 by 8 by 8, 640 voxel. 10 by 10 by 10, 1000 voxel. It's a lot of voxel, but it's really fast now. Yeah, only will render this guy. Let's scale our noise. So smaller number give us this kind of pattern. This is actually more interesting, and this can be for like level design. This is the noise passing through. This is I think it's pretty cool. Let's try not to have the gap. It's not 2.5. I wonder what's the exact number. Float. Let's plug in there, plug in there, plug in there. It's probably 2.3 to 2.2. Yeah, 2.2 seems to be good. They are touching now, and yeah, that's the beautiful 3D voxel basically. If you like voxel art, this is the thing, you know. It's quite interesting actually. How many nodes do we have in Sverchok now? It's it's around 20 nodes, under 20 nodes, and we can have this kind of design. It's quite interesting. And with the vector noise node in Sverchok, you can have this Voronoi. The Voronoi seems to be very sensitive. The crackle, maybe standard Perlin, Neo Perlin more interesting. I think the Voronoi 4 is we need a bigger number or small number. Don't know what's going on. Sometimes, oh, there you go. Something appears. Maybe Voronoi 2 point something. Smaller number Voronoi. It's very abstract somehow. And the cool thing about Blender, of course, I like the way you can just switch to orthographic like that. Very neat. Cell noise, actually one that's quite different as well. If we switch to 3D field full and then let's get rid of the grease pencil and turn on matte cap, turn on ambient occlusion, Alt A. Now we have this swimming voxel. This is actually the noise, the 3D vector noise passing through. But I like the result. It's just like the Magica Voxel app. If I go back to the compositing, make let's see. This looks like Nintendo logo. Nintendo 64. Scale it. We can, of course, instead of make it swimming in X, we can make it swimming in Y and Z. But this is the noise passing through. It's not the voxel being pushed. I kind of like the way we can push the voxel though in the Magica Voxel. Oh, this is cell noise. Cell noise is very bizarre. Yeah, back to perspective. Maybe change the matte cap. Matte cap is really cool. I want to show you one trick actually. Turn off matte cap. If you want your own matte cap and then you don't know how to create this, instead of using cycle, back to Blender render. Turn off this guy. Let's select the master object. Give it a material. This is going to be our matte cap. You go to texture, new, open, and get a matte caps. Find this matte caps library from internet. I think this is from Blender Artists forum. Matte cap collection of matte cap. I can't remember the links, but if you get the matte cap there and then you with the UV you just switch to the normal and then you switch to material, texture, or actually material, and then switch to GLSL, and you need to have light, or you just turn on shadeless. You can have this matte cap look. Sometimes actually nicer with a proper light. Shift A, lamp, point light. Can't see anything. Turn off all in render. So, one and then 2 and 3. Ambient occlusion works as well. Increase the distance. Yeah, the matte cap. back to this guy. Where's the master? Okay, switch to texture. Oh, texture actually works. You don't need to have material. Texture, and then select the material, try a different texture. Neon pink. With a matte cap, normally you just turn on shadeless, so it's a maximum brightness. Try one more thing. Metal gold leaf. It's not too obvious with a box actually. If you have monkey, if you want to make, instead of using boxes for the voxel, if you want to have monkey, you can do that easily. Just replace our voxel with a monkey. Suzanne. Now we have Suzanne voxel, and just scale it. If you have like a lot of voxel like this, it looks like start to look like a fractal somehow. And let's give it a material for Suzanne. Now the matte cap is more like a matte cap. It's gold. Smooth it. Add resolutions. Plug in the frame into the Y, and back to 3D view full, and we can see the result. I want to switch to our matte cap. There you go. There you go. That's what I want to show you. Looks like gold. Now I found the matte cap, and the OpenGL in Blender is really nice. In some other packages, it sometimes works, sometimes doesn't work, sometimes too slow. In Blender, it's just work. It's a Suzanne voxel. Yeah. Anyhow, that's I guess that's pretty much what I want to show you in this live noding. Yeah, hopefully this is useful. There's a lot you can do with voxel to make voxel art. It's like a proper voxel art is really like a more like a tedious. You add blocks one by one, you erase it, just like Magica Voxel. I don't think there is any better app than Magica Voxel, at least for now. And Blender is like kind of like a complementary, not a complementary. I mean, Blender is like a bigger 3D app compared to Magica Voxel. And you can do a lot more, of course. But with Blender, you can also use procedurally generate the voxel. You can actually use a volumetric in Blender to create something like this. What I like about this is the fact that it's a real 3D objects, and then you can scale the voxel, and then you can have unlimited voxel. Let's go a little bit crazy here. Just go like really high number just to test this. So I mean, 20 by 20 is 400, and magically it's still okay. 20 by 20 by 20, 4000. So 4000 is start to slow down, but still it's pretty interactive. And yeah, but anyway, if you have any question, suggestion, or comments, whatever, just leave a comments down below. Thanks again for tuning in to BlenderSushi channel. I'll see you in the next video. Thank you.